Hey guys, today...
Hey everyone, this is London, and my name is Mom.
Barb.
And
who's Barb? You're my mom.
We're here to record a video of our experiment that we're going to conduct tonight. So the experiment is on
soap.
Now, what about soap? The question tonight is, does soap float?
Some of you may know the answer to this. Some of you may have done this in like your bathtub when you're taking a bath. The soap does sometimes float, but we still want to test it out just in case.
So we're going to apply the scientific method to this scientific experiment. So what do we have here, London? What do we have here?
We have 3 different kinds of soaps. 3 different kinds of soaps.
What kinds? Can you read what kinds? You may want to, yeah, there you go.
Ivory.
Okay, Ivory.
Irish Spring.
Okay, Irish Spring.
Irish Spring.
And this one you may need to read on the box.
Dove.
Or Dove.
Dove.
The bird,
Dove.
you know.
It's white.
The bird.
It's a white soap.
Right. So we're going to make some observations.
And we are going to need a plate.
Okay.
We're going to need a bowl for putting all the water in the soap in.
Yep.
And we are going to need this science book right here to help us on the steps.
Yes. So, and I forgot to mention, it's a 2-part experiment. So the first part is to determine whether soap floats. So let's make some observations first before we form our hypothesis. So let's take a look at Ivory. What do you compare
feel?
the soaps?
What do you think I feel? I feel Ivory is very soft.
Okay.
This one's kind of green and hard.
Okay, good observation.
Yeah, this one's hard and green.
Mm-hmm.
This one is like, has a dove sign and it's a little bit harder than this, I'd say.
What do they smell like?
That one smells like one of those smoky things.
Oh,
like
one of the incense that we burn in our house
incense.
sometimes? Very good. Okay, that smells good.
This one smells like body wash.
Oh, good.
So that one smells good.
Okay.
This one smells like white chocolate.
Oh, that's a good one.
That
Okay.
one's my favorite.
So based on these observations, so we said Ivory was light, kind of, right? Light, smells like white chocolate.
It's very soft.
Okay.
I didn't say it was light, I said it was soft.
Soft, okay. Now, and then you said Irish Spring and Dove were kind of hard, right?
Yes.
So do you think that would help us form a hypothesis? Is it going to float? Is the soap going to float or not?
I think like one of these 2 may sink.
Okay.
And this one may float.
Okay, very good. So we have a
I'm not
hypothesis.
sure.
Do you
That
think
is
the
our
color?
hypothesis.
Do you think the color will do anything? Will affect their
color
ability
of
to
the soap?
float? Yeah. Do you think that will have any effect on the soap's ability to float?
Honestly, no, I do not think.
Okay. Okay.
So, we're gonna...
So, and what about the smell? Do you think that will have any effect on the soap's ability to float?
Maybe.
Okay.
Not sure.
So we have a hypothesis. The hypothesis is that Ivory soap will float.
Yes.
And then one of the...
Irish or Dove will sink.
Okay, very good.
Or maybe even both.
So, let's move to the next step of our scientific method.
Mom, bring the camera to the sink. We are going to fill up the bucket with water.
Well, I am ready for it. Go ahead and put the bowl right there. Go grab that water. Go ahead and pour some water in. I'll take the big one. All right, and let's get back into the camera view so our viewers can see what we're doing.
Hey guys.
Okay.
We're back and we're going to pour water into the bucket.
Go ahead and put all of it in. I'm going to just kind of top it off with this water right here. I think that's enough. Okay, let's put this back. And London.
If we need more water later, we can fill those up again.
Okay. Do the honors. Go ahead and put a first bar
Hang on,
of
guys.
soap.
I
Okay.
have a little announcement. We have never done this before, so don't think we know what's going to happen. We've never done this
don't.
before, so it's just our first time.
So, and that's why it's an experiment, right? So we're going to
And this
see
one's a little bit heavier than this one.
if our hypothesis
This one's
was
light.
right.
Okay,
So,
I will go with this one first.
Ivory.
Will it float or will it sink? It floats!
Boom!
My hypothesis for Ivory was correct. Ivory soap floats. Can I put it
Okay.
on the plate?
Yes, you can.
That's what the plate is for.
Okay. What's the next one?
Irish Spring. Sinks.
Oh.
Hypothesis is correct.
Okay.
Because I knew it was heavy, so it had to sink. This one, I'm not sure. Sink. Exactly my hypothesis.
So, we tested your
got it
hypothesis,
And we
and
got
based
the
on your observations, it seems to me that you formed a right hypothesis. We tested it, so now it's a theory. Now let's talk about it a little bit. Let me move into the view with you. So let's talk about this.
Let's get this stuff out of here. I'll move the bowl.
So, okay. So what
Guys,
we're
we're just
gonna
clearing everything out right now.
what we're gonna talk about is you can leave the camera there. Just come
Can
right
I see
here.
him?
I think we're good.
Can you see him?
All right. So let's
Okay.
talk about why. Why do you think
The ivory soap
floats?
floats.
Think about
Because
what helps us float, what floats in the water.
the reason I
Okay.
think ivory soap floats is because it is very light and it is very soft. So I think since water is so strong, the water was able to keep it up because it's so light.
That's a
That's
really
my hypothesis.
that's a really good observation.
Yep.
I will tell you a secret. Something that I know, and something that probably
Did you read it on the box?
no. It's just something I know. Probably did an experiment when I was little. I don't remember, but ivory soap has little air bubbles in it.
So it's like a sponge.
It's like a sponge. Yes.
Yeah, I can see little air bubbles in it. It's like a sponge.
So-
That's why it floats.
That's why it floats.
Because it's like a sponge.
So it's called porous. It has pores, little pockets of air inside it.
1 second, guys.
Where are you going?
Yeah, this is-
So there you have it. Ivory soap.
1 sec.
Porous. It has a whole bunch of little air bubbles inside it. Another new word for little guys out there is the word dense. We need to wait for London. Waiting. Your audience is waiting.
Chichinga! Chichinga!
Okay, chichinga. The other word that I was going to talk about is the word dense. Irish Spring and Dove are very dense. It's packed, a lot of material, really packed. There are no little air bubbles. Come over here. No little air bubbles in those, so nothing to keep it afloat. Ivory soap is not as dense. It's
very
really
soft.
light, it has air bubbles. So that brings me to the second part of our experiment.
Woohoo!
And that experiment is called soap cloud. And the fun part about that experiment is that we're gonna get to use the microwave.
Yes!
So-
Microwave! Guys,
For that, I have another bar of ivory soap. I'm gonna need a microwave safe dish. So a plate just like this. Can you get a plate just like this?
yep.
Thank you. While you're getting the plate, I will go ahead and unwrap. That's
You
okay.
guys watch her unwrap.
They're watching.
I'm gonna go get
So while London's getting the plate, I'm going to unwrap this bar of ivory soap. And this part of, that will work. This part of this experiment is closely related to what we just talked about. There are bubbles inside this ivory soap. So it won't work with any other soap. It really only works with Ivory because of the air bubbles. So there is a law that's called the Charles Law.
Okay.
Charles Law tells us...
Guys, I don't know about this.
That's okay. That's why we're talking about it. Charles Law tells us that gases expand or get bigger when they're heated. That's where the microwave comes in. So I'm going to remove this camera so I can carry it to the microwave. London, go ahead and bring the plate.
Okay.
I'm going to let you do this part. Now, yes, I'm going to go ahead and open the microwave. Go ahead, bring it. Come around.
Microwave.
And put it inside a microwave. So there we have Ivory soap on a microwave safe plate.
Should I put it in?
Ready to be heated for about 1.5 minutes. This will not damage your microwave, or at least so I read in the book, so I guess we'll find out. Go ahead and shut it. Okay, and we're going to set it for 1.5 minutes. So that's 1 minute and 30 seconds, correct?
Yep.
30 seconds, okay. And we'll press the start button.
No.
Go. Let's see.
We're gonna wait for about 1 minute. For now, we're just
Something.
gonna entertain you guys. Come on.
Okay. All right.
Now we're just gonna entertain you. Come on.
Well, we're not going to walk around the house. We're going to wait for this experiment to be through. So Charles' Law is named after a scientist named Jacques Charles. And what we see now happening is the air bubbles inside the soap are heating up, and according to the law, the air is expanding. Something's going on in there. Something is happening.
We don't know.
So it's expanding, so the soap, as you can see, looks like it's growing. And it is all because of the air trapped inside those bubbles inside the soap.
The air.
Ooh.
It looks like a cake.
Oh.
It looks like giant popcorn. Okay, that looks like giant popcorn.
Oh, isn't this cool? All right, we have 18 seconds left. Woo, this is one fluffy cloud of Ivory soap.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Bing!
So now we need to wait.
You need to wait.
Microwave is very, very hot. For everyone out there, if you're going to do this experiment, if you're kids, please get help from an adult.
Yes.
Why is that, London? Why is safety
because
important?
you may burn yourself.
Yes.
And you may not know that you need to wait a while.
Yes.
So you may burn yourself.
Yeah, I just want to wait a little bit because I don't want to burn myself. But let's see what we got in here.
Got the water?
Oh my goodness. Is this the same Ivory soap?
Looks like popcorn.
Let me get this out safely.
Let me get the bowl. I got the bowl.
Don't need the bowl.
Okay. I'll just leave it here anyway.
Okay. So this is the experiment.
So that part right there looks like paper for me.
So it
like ripped
expanded
up paper towel.
because all these air bubbles expanded. It grew into this big, beautiful, fluffy
It looks
cloud. You
like
want to touch
shaving
it?
cream.
Touch it. Oh.
It's technically melted marshmallow.
Oh.
It feels like melted
Watching your
marshmallow.
hands.
It is kind of hot.
Oh, it's just warm. But how cool is that? Yeah, is it hot?
Oh, it's hot. It's hot.
All right, it's very, very fluffy.
And hot.
So,
And all those things.
so this was our experiment number 1. I'm going to put this back.
Number 1.
We are going to...
Number 1. That's experiment number 1.
So we're going to say goodbye to everyone for today.
Yes.
We have a lot more scientific experiments planned, and we're going to record these videos and post them. And then you can like them, you can subscribe to our
channel.
Scientific channel, and we'll see everyone next time.